Hello guys, welcome to another video of mine. Today we'll be going through isometric drawings, and these are 10 quick questions that I'm going to go through with you. Multiple choice questions, okay? Alright, so the first one says isometric drawings are often used by dash or by some person to help illustrate complex designs. Isometric drawings are often used by dash to help illustrate complex designs. Okay, so the options are mechanical engineers, piping drafters, aerospace engineers, and D says all of the above. So which one is the correct answer? Okay, so I'll go through this with you. The first picture shows two mechanical engineers, and they deal with designing large complex designs such as cars or bridges or planes and that kind of thing. Okay, so that's the first one, and then the second one is pipe and drafters. These guys do drawings. If you have a oil refinery where you have a lot of pipes, they will have to do the drawings for every single pipe that is in the factory. And C says aerospace engineers, and they are similar to the mechanical engineers. However, they focus mostly on things like NASA or SpaceX or things that are going out of the atmosphere. Those will be the engineers for those. Okay, so isometric drawings, which one would be using isometric drawings? And the answer would be all of the above. Okay, so isometric drawings are 3D drawings, and all of the drafters and engineers would use 3D drawings because it makes everything understandable and much more easier. Okay, all right. Number 2 says, in order to create an isometric circle to represent a hole through the top of a box, the top surface of a box, the drafter must ensure that the correct isoplane has been selected by scrolling through the isoplanes using A, the F1 key, B, the F3 key, C, F5 key, or D, F8 key. And this has to do with AutoCAD. And as you know, an isometric circle is different from your regular circle. It's like a 3D circle. And the question asks, what would you use to represent a hole or a circle through the top surface of a box? Okay, so let's say you have the box as shown here. You have 3 planes. Remember, you have the isoplane left, isoplane right, and isoplane top. In order to switch between isoplanes to draw the circle, you need to press F5. So if you're going to AutoCAD and you want to change the planes from maybe from the left to the top, then you have to click on F5 until you get to the correct isoplane. Okay, all right. Number 3 says a fillet is a round surface on the dash corner of a part. Okay, so let's say you have a box, okay, a 2-dimensional box, and you want to draw a round surface on the corner or any corner of a shape or a 3D object. That curve would be on the inside. So for the before fillet, you see a squared edge or a 90-degree edge. After you have the fillet would come on the inside of the square. Okay, so this is the after fillet. You have a 20-degree radius, and that would give you the correct fillet on the surface. Okay, so it is on the inside of the part, okay, or the inside corner of the part. All right, number 4 says, before starting an isometric drawing in AutoCAD, the drafter needs to do something. Is it A, set the grid to isometric? Is it B, set the current layer to depth points? Is it C, turn object snap off, or is it the turn ortho on? Okay, so the grids that you see on your AutoCAD drawing, you can either have them up or down, and once they are up or down, as seen in this, the little lines that are going horizontally and vertically, that is a two-dimensional grid. Okay, if you want to change your grid for isometric drawings, however, you need to change your grid using the settings below to isometric. Okay, so the answer would be you have to set your grid to isometric, right, in order to draw isometric drawings. You can also draw it in two dimension, but it would take a longer time than if you do it in isometric grids. Okay, all right. Number 5 says a round. What is a round? A round is a round surface on the dash corner of a path. A round is a rounded surface on the dash corner of a path. Is it on the inside? Is it on the outside? Is it radial? Is it isoplane? So we spoke about the fillet in the question before, and a rounded surface. I'm going to show you the difference between the two. Okay, so the difference between a fillet and a round is that a fillet comes on the inside of a square, so usually it would come straight down and you have a sharp corner. So the fillet is like a fill, so you actually fill in the curve in the object itself, and the round is on the outside of the surface. Okay, so instead of the inside, it would be on the outside. This gives you another example, and the fillets actually help to support the object. So let's say you're drawing two pieces together. A sharp edge would actually give you a weaker joint than if you have a curved edge, and it also looks better. Okay, so as I said, the fillets are rounded inside the corners, and the rounds are rounded outside the corners. Okay, so the answer would be outside. Okay, number 6 says drafters, architectural drafters generally prefer to use dash drawings to help illustrate three-dimensional or 3D views of a structure. Architectural drafters generally prefer to use what? Is it isometric drawings? Is it perspective drawings, orthographic drawings, or auxiliary drawings? So before you answer this, you need to know the difference between all four drawings, or 4 types of drawings, and I'll show you an example of them. Okay, so here you have the difference between an isometric projection and a perspective projection. So architectural drafters, when they wanna illustrate something in 3D or make it look like it's in real life, you would most likely use a perspective drawing. Okay, and also auxiliary views are mostly for drawings that are flat or two-dimensional on the paper. If you want to know the measurement of a awkward surface, you would project it out. So this is auxiliary. Auxiliary is something that is not on the 3 planes, the top, the right, or the left. It's on a different plane, and as you can see here, it is slanted slightly, so it's sticking out on a different plane. Okay, so, and it gets awkward if you're looking at an auxiliary view. So the most regularized view that architectural drafters would use is the perspective drawing, because you are seeing it from a natural point of view. Let's put it that way. Okay, all right, so the answer would be perspective. Number 7 says the bounding box method for setting up an isometric drawing helps the drafter A. confine the isometric drawing to its maximum size, B. figure what lines are to be illustrated, vertical and horizontal, C. position the isometric drawing in a paper space, or D. none of the above. Okay, so a bounding box is the box where, let's say you have a unit and you want to know the total height of the unit or the total width of the unit, you have a bounding box around the object. The object doesn't have to be a box, but there is a cube. Well, in this case, this is two-dimensional. There is a box around the object that would be inside of the box. So you would know the height of the object and you would know the width of the object. In 3 dimensions, you will have the axis Y, Z, and X. So you would know the sizes of all 3 dimensions, Y, Z, and X, and that would give you your bounding box. So the bounding box is how far out the object goes in your drawing. So you would know the limits of that object. Okay? And here you have an example of the object inside of the box itself, or the cube itself, or cuboid, and you would know the height of the object, the width of the object, and the length of the object. Okay, so that is what you call a bounding box. So the answer would be a bounding box confines, or it keeps the isometric drawing to its maximum size, and it gives you the information of the maximum size of that object. And if you ask why would you need that, let's say you have a refrigerator and you want to know the bounding box size of the refrigerator. You need to know that in case you have to fit it into a certain space in your house or in the kitchen, or you have to take it through a door. You know the minimum size that the door should be in order for that object to pass through. Okay, and it also has to do with design and so on. Okay, so the answer would be here. All right, number 8 says the offset tool, and if you go to AutoCAD you will know where the offset tool is located. It's in the modifies tab, and the offset tool should only be used for placing dash in an isometric drawing. The offset tool should only be used for placing dash in an isometric drawing. Okay, so if you have an isoplane, as I said before, the only thing that you would be able to offset are the vertical lines. Why? Because the circles would be in a slanted position. The horizontal lines would not exist because you don't have them in isometric drawings. Remember, this is not a regular drawing. This is an isometric drawing with the angles. Okay, so to offset it, you would offset the vertical lines only. Okay, so the vertical lines in the drawing would be offset, and here is where the offset button is in the modifies tab. Okay, here you have an example of the isometric drawing, so only the vertical lines you would be able to change. Okay, and here you see 2 parallel vertical lines, and they are offset using the offset tool. Okay, all right. Number 9, when creating an isometric drawing in AutoCAD, the drafter can utilize the dynamic input and polar coordinates. Remember, we spoke about polar coordinates in a past video. This has to do with X, Z, and Y axis system to place both vertical and horizontal lines. A line created from 1.3 inches at 180 degrees would be a dash line. So they're basically saying when you're creating an isometric drawing, if you want to make a line at 3 inches at 180 degrees, what type of line would it be? So let's look at the polar coordinates below, and if you look for 180 degrees, you will see 180 degrees is horizontal. Okay, so that line would be horizontal. You always want to look at the degrees that you're putting the line in. So if it's 0, it would be horizontal. If it's 180, it would still be horizontal. Okay, so the answer would be horizontal. All right, and the last question, number 10, AutoCAD refers to isometric ellipses as, if you don't know what an ellipse is, Google it, find out what it is, and then come to the question and you will be able to answer it, okay? AutoCAD refers to isometric ellipses, not two-dimensional ellipses, as A, ellipses. It can't be that because it's an isometric ellipse. Iso-ellipses, there doesn't exist a thing called iso-ellipses, isocircles, or circles, and it can't be circles because circles are a regular two-dimensional object. So the answer would be isocircles. And here's an example of what an isocircle is. It's similar to an ellipse, but in the isoplanes it is drawn as a circle, okay? And here's an example of isocircles on a regular isometric drawing. You have one at the top and one in front. And if you look closely, you will see that they are not rounded like a regular circle. They are more narrow, and these are called ellipses or isocircles in an isometric drawing interface, okay? All right, so that's it. Thanks for watching, and I'll see you on the next one. Try and answer the questions on your own, and if you understood, please hit the like button. If you haven't subscribed yet, please hit subscribe. We have reached 800 subscribers, so I thank everyone for subscribing to the channel, and I'll keep posting videos when I can, okay? All right, thanks for watching. Take care. I'll see you on the next one. Bye.